Welcome to this new section of the course. In this chapter, we will learn to analyze the data for a better understanding using exploratory data analysis techniques. Let's begin. Exploratory data analysis, or EDA, is a process to investigate a dataset in order to identify patterns and anomalies in it and to summarize the main characteristics of the dataset, often using various graphs. In this chapter, we will learn to perform EDA on data using Python. Univariate analysis means to analyze the data based on one variable or column. This type of analysis gives a general overview of the dataset and helps identify patterns in it. Techniques to perform univariate analysis vary depending upon whether the data is categorical or continuous. Categorical data is the data which is discrete, i.e., which can be classified into different categories, e.g., an email could be spam or no spam. On the other hand, continuous data is the data that can take any value, e.g., height of population, etc. We will see how we can perform univariate analysis on the two types of data. Consider the data frame given in the slide. Let's call this data frame DF. The data frame contains four feature columns, namely sepal.length, sepal width, petal length, and petal width, and one output column, namely variety. All the four feature columns are continuous and the output column is categorical. The data frame contains information about 50 instances of setosa, versicolor, and virginica each. We will learn to perform univariate analysis on continuous data using this data frame. Scatter plots can be used for the exploratory data analysis of univariate continuous data. In the given figure, we plot the petal length variable of the data frame using the .scatterplot brackets method of the Seaborn library. We learn that virginica plants have greater petal lengths as compared to the other two varieties. In this tutorial, we will use scatter plots for the univariate analysis of the continuous data. We have our data frame from the slides. It is called DF. We have already imported Seaborn and Matplotlib libraries. Our x-axis will be the index column if the data frame and y-axis will be the petal.length column of the data frame. x_axis equals df.index. y_axis equals df square brackets petal.length close square brackets. Next, we will use the .scatterplot function to create a scatter plot with the above x and y axis. We will also pass the variety column of the data frame to the hue parameter of the .scatterplot method. The hue parameter assigns different colors to the data points based on the category they belong to. Also, we have imported Seaborn as SNS. SNS.scatterplot brackets x equals x_axis, comma, y equals y_axis, comma, hue equals df square brackets variety close all brackets. We execute this cell and the output is similar to what we saw in the slides. We can also use a strip plot for the univariate analysis of the continuous data, which gives the distribution of the data. The plot in the figure gives a distribution of petal lengths for each of the 3 varieties of the iris plants. Let's see how can we plot a strip plot in Python. To plot a strip plot, we will use the .strip plot method of the Seaborn library. On the x-axis, we will have the different varieties of the iris plants, and on the y-axis, we will have their lengths. sns.stripplot brackets x equals df square brackets verity, comma, y equals df square brackets petal dot length close square brackets. Let's run this cell. We can see the output graph showing the distribution of the lengths of each variety. Distribution plots are used to visualize the overall distribution of the data. In the given figure, we have used the .distplot method to visualize the distribution of the petal.length column of the data frame. To plot a distribution plot, you use the .distplot method of the Seaborn library. Note that upon executing the cell, you might get a warning that the function is deprecated. You can ignore this warning for the time being. sns.distplot brackets df square brackets petal.length close all brackets. Run this cell and we will get a graph showing distribution of the data. A histogram is used to plot the frequencies, which at times can be useful. We can use the .hist method of the matplotlib library to create a histogram. In this tutorial, we will plot a histogram using the .hist method of the matplotlib library to see the frequencies of values in the petal.length column of the data frame. plt.hist brackets df square brackets petal.length close all brackets. Execute this cell. We see that most of the plants have petal lengths between the range of 1 and 2. A box plot is a very powerful tool that provides a 5-number summary of the data. It tells the minimum and the maximum values, as well as the 3 quartiles of the data. In this tutorial, we will learn to plot box plot using the Seaborn library. sns.boxplot brackets x equals df square brackets petal.length close all brackets. Run this cell. We get a box plot. From this box plot, we can estimate that the minimum petal length in the data frame is around 1, and the maximum petal length is close to 7. We can also visualize the first, second, and the third quartiles. Now we will perform univariate analysis on the categorical variable of the data frame, namely verity column. The .count plot method of the Seaborn library gives the total count of each category in the data frame. From the count plot in the given figure, we can see that we have 50 instances of each of the 3 categories in the data frame. Let's create a count plot using the Seaborn library. sns.countplot open brackets x equals df square brackets verity close all brackets. Click run and we have the output. A pie chart can also be used to visualize the proportion of each category in the data frame. Let's see how this works. Recall the .value_counts method gives us the count of each value in the data. We can use this function combined with the .pie method of the matplotlib library to create a pie chart showing the proportion of each category in the categorical data. Let's start by creating a list of labels. This is not compulsory. However, it is a good practice to have labels with the graph. Underscore labels equals square brackets Setosa, Verisocola, Virginica, close all brackets. Next, let's create the pie chart. plt.pie, open brackets, df, square brackets, verity, close square brackets, dot value underscore counts, brackets, comma, labels equals underscore labels, close all brackets. We finally run this cell. The pie chart shows that all the three categories are in equal proportion in data. Bivariate analysis, as the name suggests, means to study the relationships between two features of the dataset. Consider the data frame given in the slide containing information of the passengers aboard the Titanic. Let's see how we can perform bivariate analysis if both the features at hand contain continuous data. Scatter plots can be used to visualize the relationship between two continuous features or variables. In the given example, we plot the age column of the data frame against the fare column, both of which are continuous. We can understand from the scatter plot that the two variables are pretty much independent of each other. Let's see how we can plot a scatter plot like the one in the slides. We have our new data frame loaded in the variable df and the libraries are imported. We will use the Seaborn library to plot a scatter plot. For more clarity, we will also add a title to the graph. sns.scatterplot, open brackets, x equals df, square brackets, fare, comma, y equals df, square brackets, age, close all brackets. plt.title, brackets, bivariate analysis, close brackets. Click Run to get the output. And here we have the same graph as shown in the slides. We can also use the .core method in the Pandas library to find correlation between two or more variables of the data. A high number suggests that the two variables in question are significantly related. Let's see how we can do this in Jupyter Notebook. In this tutorial, we will use the .core method to find the correlation between the fare and the age column. In the previous tutorial, we learned through the scatter plot that these two variables were independent of each other. So, we should get a low correlation between them. Let's see if this happens or not. df, square brackets, fare, comma, age, close square brackets, dot, core brackets. Click Run, and we get a data frame that shows us the correlation between the two variables. The correlation between fare and between age and age is 1, which makes sense because every variable will have a maximum correlation with itself. The correlation between age and fare, or between fare and age for that matter, is very low, just as we had expected. We can also plot the resultant correlation data frame that we saw in previous slides using a heat map. A heat map represents different numerical values using color codes, which is visually very helpful, especially if you are studying the correlation between more than two variables. Let's learn to create a heat map in Jupyter Notebook. The .heatmap method of the Seaborn library takes the correlation data frames as an augment to generate a heat map. sns.heatmap, open brackets, df, square brackets, fair, comma, age, close square brackets, dot core, close all brackets. Let's run this cell. Get a heat map. The guide on the right tells that the brighter the colour, the higher the correlation. Again, we can see that the correlation between fair and age is very low. If the two variables at hand are both categorical, we can use a bar plot for the bivariate analysis. We'll use the same data frame that we saw earlier and analyze the columns P class and survived, both of which are categorical variables. Our goal is to visualize the survival rate of passengers belonging to each of the three categories of P class. Remember, there can be multiple ways of doing this. For the sake of simplicity, we divide the solutions into two steps. We first get a smaller data frame with the two variables that we are interested in and group this data frame based on P class. Next, the survived column contains 1 for the passengers who were able to survive and 0 for the passengers who were not. Therefore, if we use the aggregate function sum, we will get the total number of passengers who survived for each category of the P class. In the next step, we simply use the .bar plot method of the Seaborn library to create a bar plot. Let's implement this two-step solution in Jupyter Notebook for a better understanding. Okay, for the first part of the solution, we use the .groupBy function and apply the aggregate function sum to get a data frame containing the survival rate for each category of P class. Survived underscore ratio equals df open square brackets P class comma survived close square brackets dot group by brackets P class dot sum brackets survived underscore ratio. Run this cell. We get the desired data frame. Now, it is clear for this data frame that more passengers from P class 1 were able to survive. However, in case of multiple categories in a categorical data, it is better to graphically visualize this information. So let's create a bar graph. On the x-axis, we will have P class and on the y-axis, we will have survived. SNS.barplot brackets x equals survived underscore ratio dot index y equals survived underscore ratio square brackets survived close all brackets. Run this cell and here we have the bar graph. Next, we will learn to perform bivariate analysis on continuous and a categorical variable. We will use the same Titanic data frame. We can use a box plot for this kind of bivariate analysis. Let's jump to Jupyter Notebook to see how it works. We will plot a box plot using the age column, which is continuous, and the survived column, which is categorical. SNS.boxplot open brackets x equals df square brackets survived comma y equals df square brackets age close all brackets. Execute this cell. The box plot suggests that the younger people had a greater chance of survival in the disaster. We can also plot a bar plot for the bivariate analysis of a continuous and a categorical data. Let's see how. Let's plot a bar plot to see whether the elders on board the Titanic were more male or female. A 1 in the sex column represents a male passenger, while a 0 represents a female passenger. SNS dot bar plot, open brackets, x equals df, square brackets, sex, comma, y equals df, square brackets, age, close all brackets. Run the cell to get the output, and we understand from the graph that the elderly passengers were more male than female. In previous sections, we discussed what outliers are and how to detect them. To refresh your memory, an outlier, also called an anomaly, is the observation in the data that is very different than the rest of the data, hence creating an anomaly. In this section, we will learn some basic techniques to deal with outliers in the data. A very naive approach is to delete the outliers from the data after detecting them. Consider the given series, for example. It is easy to say that the value of 150 is a potential outlier. We compute the z-scores of each value in the series x as shown in the first figure on the left. We then keep only such values of the series x whose z-score is less than or equal to 1.5. As shown in the figure on the right, value 150, which was the outlier since its z-score is greater than 1.5, is not included in the output. So, outliers underscore removed is a series we get after trimming outliers from the series X. Now, let's actually see it in Jupyter Notebook. We start by creating a series as shown in the figure in the slides and computing the z-score of each value. Please note that we have already imported all the required libraries to save time. X equals pd dot series, open brackets, open square brackets, 1, 2, 3, 6, 7, 8, 150, close all brackets. Mean equals x dot mean brackets. std equals x dot std brackets. Z underscore scores equals abs, open brackets, x mean, close bracket, / std, close brackets, z underscore scores. Let's run the cell to see the output. We can see that the value of z-score corresponding to value 150 is 2.2. In the next cell, for the sake of simplicity, we will create a new series called Outliers underscore removed, which will contain only those values of series X for which the z underscore score is less than or equal to 1.5. Outliers underscore removed equals x square brackets z underscore scores is less than or equal to 1.5, close square brackets, outliers underscore removed. Click run to execute this cell. And as you can see, the value 150 is not included in this series. Another way to deal with outliers is to replace them with either mean or median after detecting them. Let's see how we can do this. In this tutorial, we will learn median imputation for outliers treatment. We create a series as shown in the figure in the slides and compute the z-scores of each value of the series and the median of the series. X equals pd dot series, open brackets, open square brackets, 1, 2, 3, 6, 7, 8, 150, close all brackets, mean equals x dot mean brackets, std equals x dot std brackets, median equals np dot median brackets x. Z underscore scores equals ABS brackets x minus mean, close bracket, divided by STD, close all brackets, median. Execute this cell, and the median is 6. Next, we replace all values of series x with z-score greater than 1.5 with the median value of x. This is very easy in Pandas. X square brackets z underscore scores is greater than 1.5 close square brackets equals median x. Let's run this cell to see the output. And as you can see, the last value is replaced with the median value.